As winter bites, more electric vehicle drivers are being stranded on the roadside. The cold is affecting batteries and reducing the distance the cars can travel on a single charge. We get you more details in this report.
Countries around the world are pushing for electric vehicles. Automobile firms are working hard to revolutionize the EV sector. But there are many challenges facing the EV industry. One such is cold weather. It's been discovered that extreme cold temperatures can lower the range of electric vehicles. They do not charge as quickly in extreme cold as they do in hot weather. According to reports, performance analysis of electric vehicles in freezing temperatures shows that heating the car can lead to 39% more battery consumption in the first hour as compared to normal weather conditions. This means 18% less mileage on a full battery charge than in the summer. Meet Steve Carrigan, a resident of the United Kingdom. Carrigan's EV normally gives an average of around 131 kilometers on a fully charged battery. But that drops to 72 kilometers in the intense cold weather. It's well known that EVs lose some of their travel range in the cold, especially in sub-zero temperatures. Studies have found that the range loss varies from 10% to 36%. Carrigan has learnt it the hard way that in peak winter, sometimes it's better to find an alternative way to travel.
If I've got an event on the weekend and it's forecast to be a really cold snap like this, I have no option but to go and hire a van.
Steve is not the only one running into problems with electric vehicles. Frigid temperatures have made life painful for electric vehicle owners in the United States as well. Some Tesla owners in the United States have also reported that their cars wouldn't charge at all. They're also dealing with reduced driving range. Hours of waiting at charging stations is another issue. Royal Automobile Club, commonly known as the RAC, that's a British roadside recovery service, says 6% of call-outs to EVs are because they've run out of power, a far higher percentage than petrol or diesel cars.
A petrol engine or a diesel engine, if it does break down, you can roll it, you can move it to the side of the road. With an electric vehicle, it can be quite challenging to recover that vehicle at the roadside if you can't get the steering and the wheels to move.
So the question remains, why do electric vehicles face battery issues in frigid weather? Understand that almost all electric vehicles use lithium-ion batteries. Lithium ions flow through a liquid electrolyte and produce electricity. However, in cold weather, the lithium ion travels slowly and does not release as much energy. That cuts into the range and can deplete a battery faster. The same happens in reverse as well. Since electrons move more slowly, the battery can't accept as much electricity from a charging plug, and this in turn slows down the charging. In other words, the problem is that when temperatures plunge, batteries have to be warm enough for the electrons to move, and they have to be even warmer at fast charging stations. Experts acknowledge that cold weather can be hard for electric vehicles, but with some planning and a little adjustment, owners should be able to travel pretty much as normal.
Okay, so the top tips are, while the vehicle's plugged in, I would get the vehicle preheated. Again, that helps my range. Regular maintenance of the vehicle, tyres are checked, good tread on the tyres and good tyre pressures.
Also, Bruce Westlake, president of the Eastern Michigan Electric Vehicle Association, says that almost all EVs are programmed to warm the battery if the driver tells vehicle's navigation system that a trip to the charging station is coming. So, it's important to precondition the car before charging. In short, EV drivers need to plan ahead, especially in cold weather. Interestingly, the battery technology will continue to get better. In the coming years, automakers are likely to come up with better ways to protect battery life and warm them for charging. Scientists are also developing new battery chemistries that will be more resilient in cold weather.